Hello everyone. Welcome back again to this uh, Python programming master class. Now we are going to discuss about our next topic, that is recursion. Okay. So basically, this is a very important part of this series. You can say playlist, and this is very important. And some people get too much confused in this section. So I'm going to discuss about recursion in detail within few minutes. Before beginning to our topics, I would love to introduce myself. So my name is Manpreet and welcome to my YouTube channel. Now we are going to start our video. What is recursion? What is recursion? Recursion is a programming technique in which a function calls itself to solve a problem. The problem is divided into smaller subproblems until stopping condition base case is reached. Okay? Have you got this point? No. If no, I will repeat it again. Recursion is a programming technique in which a function calls itself. When a function calls itself to solve a problem. That means that function call itself again and again until the base case is at until that it doesn't stop until that base condition is reached. Okay, so we are going to discuss about a real life example. Okay, imagine that you are standing here, in front of you there is a mirror, and backward you also have a mirror. Now you are standing between the mirrors. The image you guys saw is repeating image again and again. The again and again repeating image is known as recursion. If I talk about in coding word or programming language, this is known as recursion. That means that you are standing between two mirrors. This repeating pattern is similar to recursion. You can't say that this is recursion. Standing between two mirrors, you can't say that this is recursion, but it is actually similar to recursion. Okay. Now, components of recursion. Every recursive function has two important parts. Okay. First one is the base case, the condition that stops the recursive call. Have you got the point? Okay, I will tell you again. The condition that stops the recursive call. After that, no more execution. Okay. Recursive case, the part where the function call itself with a smaller problem. We are going to discuss about this in brief, or you can say that. Okay. General syntax. Def, function name. What is def? Def. That is used to describe the function. It is function name, then n is a parenthesis. N is inside parenthesis. That is known as parameters. N is inside the parenthesis, that is known as parameters. If base condition. Okay, if base condition, then return that value, else return function name or the smaller problem. How recursive works? Very important, very important. First, you have to define that this is a function. Now, the name of the function. After that, parenthesis. Then, this is parameter. This is parameter. N is parameter here. Okay? If n is equal to 0, if n is equal to 0, that means that if the value of n is equal to 0, that means 0 is equal to 0, then print done. Else, if n has value 1, 2, 3, 4, 5, 6, then print that value, then the countdown would be n minus 1. Then the countdown would be n minus 1. Then this will give 5, 4, 3. Okay? Yeah, 5, 4, 3, 2, 1. Okay, we are going to code this. First, I will comment out this def, then the name of the function. We would love to do this one, count down n. What is n here? Okay, I will write it. N, oh sorry. N is parameter here. Okay. If n is equal to 0, then return print print done. Okay. Else, if n is not equal to 0, that means that print, but actually we want to print n, and I am going to describe what is the countdown. Countdown will be n minus 1. Okay, yeah. Now we are going to describe. Now we are calling this with 5. That means the value of n would be 5. Value of n is equal to 5. Here, I'm going to run this code. 5, 4, 3, 2, 1. Okay. First it checks that 5, okay, 5 is not equal to 0, then else will be printed. Okay. After that, n minus 1, that means 4. 4 is not equal to 4 is 4 is equal to 0. It checked that. No, it was not equal to 0. So it printed that 4. Then 3. 3 is equal to is 3 is equal to 0. Then it said that no. Then 3 is printed here. Then again 2 is checked. Is this equal to 0? Then no. In this manner, okay, what happens if I write 10? What happens if I write here 10? Okay, 1. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 would be the answer. And then done. Okay. I hope so that this will be clear to you guys. Now we are going to discuss about more questions. A very important question also, where you will get information how the recursion will work. Okay. Execution flow I already discussed with you. First, it checks that. Okay, first check 10. then 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1. After that, it after that it the base case is true, which means which means that n is equal to 0. So it print done. Okay. Yes. I hope so that that's clear to you guys. Okay. What are the advantages of recursion? Like, is there any advantages of using recursion? Yes. Now we are going to discuss about this. Codes become shorter. Okay. Easy to solve tree and graph problems. Useful in divide and conquer algorithms. Natural solution for mathematic problems. I'm also going to discuss about mathematical problem. This one point, this point, disadvantages of recursion. Uses more memory due to function calls. Okay, can be slower than loops. Yes, that's obvious. It has to we have to call it again and again until that condition satisfied. Missing base call infinite recursion. Yes, that actually happened with me when I was learning recursions. In my first semester, I have created infinite recursion where I was using not a good laptop. Then I have to quit exit that program, and after that my laptop starts working properly until that it was not working properly because of the infinite recursion. Python has a recursion depth limit. We are going to discuss about this point later on in our journey of Python master class. Now, the very important and very interesting question: Fibonacci series using recursion. What is Fibonacci series? Okay, so we are going to discuss about this. Okay, first we need to know that what actually it is, why it is used, what is Fibonacci series. Okay, each number is the sum of the previous two numbers. Okay, yeah. This one is Fibonacci series. Okay, we are going to do it on what we have learned so far. It is the sum of previous two numbers. First we are taking 0. Sorry. First we are taking 0. After that 0 added with 1, then it gives 0 plus 1 rise to 1. Then 1 plus 1 gives 2. Then 2 plus 1 gives 3. Okay. 3 plus 2 gives you 5. Okay. 5 plus 3 gives you 8. Sorry, 8. Okay. 8 plus 5 gives you 13. Yes. Okay. Then 13 plus 8, 21. Okay. 21 plus 13 gives you 40. Yeah. No, no, sorry, sorry, sorry. Okay. This is the beauty of Fibonacci series. Now we are trying to do a code and series. We are going to write a code of this series. Def. What is def? Def. First, I will comment out this one. Okay. Def. Def is a keyword to show that it is a function, beginning of function, to show the function. Okay. Now we are going to write the name of function. Okay. Sorry. Okay. N. What is that? This is the name of the function and n is parameter here. Now we are going to give conditions. If n is equal to 0, then return 0. Okay, sorry, return 0. Elif. If n is equal to 1, then return 1. Okay, else, else. These are the base conditions. These are the base conditions. Okay, these are the base case. But now we are going to describe about recursive. When a function calls itself, these are the recursive case. Okay, else return that function name n minus 1 n-1 plus function of n minus 2. Now we are going to describe that what will be the n, what actually n is. Okay, now we give that what is the value of n. For now we are going to print it. For I in range, what will be the range? Range will n. N for I in range n. Why it is splitting? Okay, leave that. Print that fib series I. Okay, now I comma, and we are going to end it with end is equal to this. That means if we didn't make this, you will see something. This will come with the whole series, and you would be not able to learn. Actually, think properly. First, I will clear that. Clear the terminal. Now I'm going to run it. 0, 1, 1, 2, 3, 5, 8. What I have written over there? 0, 1, 1, 2, 3, 5, 8. What happens if I write 9 over there? 13, 21. I've discussed that case with you. Now I'm going to 10, 34. We have counted it, and we have took too much time. We have took too much time to calculate it manually. Yeah. First we were taking okay, 0, 1. It will give rise to 1, 1, 1, 2, 2, 1, 3, 3, 2, 5, 8, 5, 13, 13, 8, 21, like this. We have to calculate it in our mind. But if I use the simple code, okay, fine. Till here it is fine. But what happens if I want like this? Then it is not possible that I have to calculate it in a like calculate it in again and again. Okay, sorry, you can't use it's all two numbers. I apologize. I apologize. I have to write that code again with one more plus. Okay, so this is all about the Fibonacci series and how actually it works. I already discussed the code and the portion with you. Now the factorial using recursion. Okay. I'm giving you 5 minutes to solve this question by yourself. Factorial. Okay. First, I will tell you what is factorial. 5 factorial is equal to 4, 3. This is factorial. That means you have to multiply this value till 1. Till 1. That's it. If I write, if I write 6 factorial, then it's very simple. 6 into 5. That's it. This is factorial. Now you have to do this code. Okay. Okay. Def factorial, then n, if n is equal to 0 or n is equal to 1, then what will happen? Print return 1, then return 1. Okay. Else, if you have this, then print factorial of n into, then return, n into, okay, that's it. This is all about factorial portion. 120. 5 into 4, 4 into 3, 3 into 2, 2 into 1. Okay. You can also perform these kind of questions. Sum of first n natural numbers using recursion. Key points for exam. Okay, so key points for exam would be recursion means a function calls itself. What is recursion? Actually, recursion means a function calls itself. Okay, every recursive function must have a base case. That's the key feature. That's the key point. You have to be in your mind. Every recursive function should must have a base case. Recursive call should move toward the base case. If this is the base case and this is the recursive case, then the recursive case needs to be in level with the base case at any condition. More in simple words, one should be static. That base case should be the static. You just have this is the tip to remember that. Actually, this is not happening. Base case and this one is the recursive case. Base case should have power to attract recursive case. Recursive calls should recursive calls should attract it towards the base case. Okay. Fib, nonic, and factorial are the classic recursion examples. I have given you example of this Fibonacci series, and I have explained it very properly as per my opinion, as per my book of knowledge. I have done too much to understand you to this series, but this is, I have done too much to make you sure that this is all about this series. Then the recursion uses more memory than loops. Recursion uses more memory than loops. Sometimes, if you use recursion, it is like more good. But sometimes, but if you have approach, if you are using approach of loops, then it seems that you are a very good developer because that's quite easy to understand also. Common recursion applications: Fibonacci series, factorial, tree transversal, graph transversal, and divide and conquer algorithms. You guys will study these tree transversal and so on this in algorithm chapter in data structure and algorithms also. So this is all about recursions. You have to study it very well because this is a very important topic and a little bit confusing too. If you are solving the questions of recursion, then you have to be a very have attentive minds because that's important topic and you have to give extra some time to uh, use this. So this is all about the recursion topic. Now we are going move forward to the another topics of Python programming, and we have done so far, and we have done too much about Python, and we are trying our best, and I'm also trying my best to deliver my speech, to deliver my knowledge, to deliver my knowledge about Python. Sometimes I feel fumbled and I feel that I'm not able to interact properly, so I'm sorry for that. But actually I'm trying my best.